Hello, my fellow YouTubers, my TikTokers, and also my internet sensations. Today we're going to pick up on yesterday's video. Skybolt had a few questions, and I believe we touched base on it yesterday, but 10 minutes wasn't enough for me to explain it. So we'll pick up a little bit on it today. Let's start off with the questions that Skybolt had raised yesterday. He said he would like to find out the answers to these questions. The questions was, does an audio frequency through a primary and a transformer step up to a higher voltage? Yes, there is a step up in the process as a Tesla setup as well, and the easiest thing that I thought for explanation into that question would be to just take a CB radio, which puts out 5 watts. It's not a lot of watts, not a lot of power, but we're able to store power and transmit it wirelessly and collect it. So that's very important, I believe. The second question was, does the north and south repetition make an audio signal? And that's a great question. And in regards to dipoles, which I believe the question is really asking, does the north and south repetition make an audio signal? Well, the answer is yes. And if we want to touch base a little bit, we'll look at a drawing that I drew out a long time ago on a circuit of light. So the circuit of light is basically a coaxial circuit. You have a transverse field pulses is what we're dealing with. Transverse wave is propagation and travel, which creates nodal points and time, by the way. And then pulses are your individual pulses. Now, they call these nodal points photons, but as far as I'm concerned, there really isn't any photons. These areas here are dielectric pulses. The dielectric is created within the ethereal space of inclusion, meaning that this is a pushed out wave. You are having your electrical and your magnetic poles here, like your question, Skybolt, and these will flip on every time it hits a nodal point, and the nodal point is like a neutral point. A couple things I'll bring up here in color of the light, that blue light has more points, more nodal points in it, than red light has less nodal points. Why would that be important? If we're transverse audio signals and propagation through space, the light that it produces will have nodal points based on its frequency, but it also matters on light, especially when we're talking about sunlight propagation versus audio. Audio would, I don't know how you would, I'd have to think about that one there. If I was designing a system of audio, and the color of the light would have more nodal points to me, meaning that it would be a higher frequency, I would think, than red light. I'll have to look into that. It's a great question I just came across. So back to propagation of light itself. You'll have your magnetic and your electric on either side. There goes your AC, and then it flips over. Your nodal points are your dielectric pulses, which is punching, which is the ether taking back control of what just happened, and the ether bringing back. That's why I always say it needs a wall. Out in space, ether itself is a congealed gel of everything, and it's just waiting to be pulsed. It wants to be played with. So let's move on to turning on the CB here. CB. Should be on. Oh, good. All right. CB's on. Breaker. Doesn't matter what channel you're on. Let's put on the voltmeter. Let's get you off of your stand. Whatever it. Got no volts on the meter. We're going to go ahead and just click on, and you're going to see energy show up. Where is that thing? So here is the antenna for it. Here is the full wave bridge rectifier on the back there. It's just 4 diodes set up. How I say it's funny. 4 diodes set up as a full wave. Go online, look up a full wave bridge rectifier. It takes AC and puts it into DC. Diodes are pretty cool. So I have that, and that's it by itself. It's connected to the voltmeter, and with it itself, I'm just going to go here and click it. Here's my antenna, and look at that. I'm already up to 3 volts. If I talk in it, break. I'm up to 7 volts, 6 volts, 7 volts. Breaker. Sorry, so we got voltage, baby. It's DC. Let's go to 20. 8.9 volts. So you got that. It's pretty interesting. So think about what's going on here. Audio, meaning I'm talking in here, breaker, tested 1, 2. So remember, we're taking elements, is what it is. We're creating a molecule. We're sending bunches of them down the path. They're traveling, they are turning. Now, how they're turning, whether they're agitating or turning, that's on it to know. But they're flipping, and they're showing up here on this piece of metal, which is going down the wire. This is crazy. And then we're separating the electrons directionally to go into these 2 plates in this electrolytic capacitor, and here we are, stored energy, okay? And not connected. This is just wireless. This is basically itself pretty unbelievable. It's fascinating that can be done. So that's one thing to show you guys out there. Number 2, The fact that I can hold this LED, now the secret here is I got a diode connected to the LED as well in a certain manner, where the positive, where the ring is on the positive side of the diode. The other negative side is just an antenna. And when I hold that antenna, which let me get you back on the stand here. I hold the antenna, not the antenna, and I hold this light here. So I'm just gonna hold the antenna up. I got my finger on there. And every time I click on breaker, 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 test it 1, 2. Test it 1, 2. Test it 1, 2. See the light light up when I talk? So basically here is electricity and you're seeing it through light. So as I talk, you will see the light light up brighter and dimmer. Break, 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 break. So when I talk right now, I'm transmitting molecules from that antenna to my receiver right here. How am I receiving? That is the $1 million question, you guys. How am I able to receive these molecules? Breaker, 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 break, break. So my voice becomes molecules in space and time traveling. They also become an energy source. Break, 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 break. There goes your light, there goes my voice. All right, so fascinating. I find it fascinating. Didn't understand why I never put it out there to you guys. I was playing with this years ago. Small doses of Tesla, I guess. So here we can transmit. We are, with any transmission that's audio is bound by its transverse, it's built in, or how is it? It's transverse square law, I would say, meaning that power out, power back. So you would have like a triangle here, and then it comes out. And what you have here is a south pole here on this transmission. And at the bottom you have the north pole. And then you have this is rotating constantly from every time its frequency flashes, it's flipping. And as it's doing that, it's sending out these punches. And the punches are going in every direction. And the punches are these transverse audio versus light. But it's the same premise, the mechanics are the same. You just don't have all the goop that's inside this circuit of light. You are functioning the same. You are having magnetic flipping with electricity. They're always off 90 degrees from each other. They are in a rotating right-hand fashion. That's how it works. And back to the question on Skybolt, can audio signals run a motor? I guess anything that's stored can run a motor, so why don't we have, and you're wondering why the electricity shouldn't have run out of the capacitor that fast. So let's click that on. You still got 6 volts on that capacitor, and we can breaker, 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 tested 1, 2, tested. You gotta put the antenna up in the air, And then we're gonna breaker. Test it 1, 2, test it 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. All right, so yes, you can run a motor, but can you run a motor off free audio that's running out there would be my question, because it's out there. Everything you're looking at out in space itself has signals running through it. So can you collect them? Can you pirate some signals? Sure you can. Can audio signals generate power? Obviously, yes. More experiments. If you guys would like any more on the audio, remember with this audio, the main components. There's a couple things here. One would be a crystal. So we're using a crystal for a steady frequency going out of this CB. And then we're using a crystal as a receiver to take that energy and to do something with it, like store it. So we're able to capture the energy in a capacitor using diodes with crystals in them. So we could find the resonant frequency of this crystal and this crystal, which I know are in the same broadband. So we're able to fine-tune the receiving. We can fine-tune the transmission by going up in amperage, more wattage. So if we went out, say if we put a microphone on here that was a amplified microphone, we can increase the amperage of this little unit going out, which therefore would produce a lot more energy stored. You would build capacitor arrays to store it. It would should be able to collect randomly off, say, little antennas on your roof. Connect it to ground. It creates the dipole, which therefore would capacitor tune yourself, maybe to the Schumann. Things out there and that should be studied, guys. You young bucks need to get out there and do your job. Get busy. Report. Send your comments. All right, hopefully 17 minutes, not too long of your time. Yeah, this is just touch and base, guys. This is just a small fragment. Any more audio tests you want, please, Skybolt, anybody else, leave your comments. I broke out my transformer. It's a Flyback. We're going to do an experiment with this. We're going to use this setup here to make, I'm going to make 2 vacuum bottles. We're going to do some tests with plasma. And I think the next level of the onion, I'll call it, of audio is what happens to audio out in space where there's negative pressure in vacuum of space. What happens to the ether, the congealed space stuff goo in it itself? What happens to light? Light propagates out in all directions from the sun, not stopping at all. But I like to be able to do one test that I think would be fascinating is we'll use this Flyback. These Flyback generators is exactly what Skybolt was asking on. Does the audio frequency through a primary in a transformer step up to higher voltage? So yes, here's your Flyback. We'll put 12 or 24 volts into this, whatever we desire. Probably make it variable so we can increase and decrease the pressure. This Flyback has to have DC pulsed, and when you do DC pulsed, you are creating a agitating directional field in the lines to happen, and also it happens in this coil that's in here, steps up the voltage from this primary here, which is like 8 turns of a thicker wire that you'll come out of this driver here, which is 12 or 24 volts, and has 2 0-point capacitors, which allow the capacitors to fully drain out. They are both working off a oscillator to a certain frequency that's set, I'm sure, by a crystal in here, and that drives the driver right here, which steps up the voltage to high voltage to run the TVs. This is your original OG TV transformer, high voltage, and one of these pins here would be the negative. And that creates, like for instance, let me show you here, just on this little nice beautiful piece of machinery, we can take this 12 volt, just come over to the feed side, so there's your 12 volts going in. Now that thing is on. Wouldn't want to mess with it, but it is on. Here's your high voltage from 12 volts. Very high voltage. So you can look at the voltage by the distance of the gap between those two, and that'll tell you you're probably at least 100,000 volts. That was at least an inch gap, and that's only 12 volts. You can do 24 volts. These things are pretty cool, and yeah, it's held a little electric in there. So what we're going to do with that experiment, dig it up maybe tonight or tomorrow. We're going to make the bottles, vacuum the bottles to a negative pressure, put electrode in them, and what we're going to do with this experiment, we're going to check to see what happens in propagation of audio through vacuum, and then we're also going to build, if you look at this, how this toroid here, which is a concentration of electrons that are there at will for the capacitors here, but they do put up a fight and don't like change. So when they're blessed with one dose of positive and then they go to get drained to negative, they put up a big resistance. That allows the capacitors to be flipping on and off without lack of power on any occasion, no matter how fast you pulse them. What I like to do is take the toroid, take the donut off, but build the coil as an air coil and put it around, let's say, what we're going to do is take these bottles, okay, would be a good experiment. We're going to, here you guys, you're going to like this. We're going to take these two bottles, and what we're going to do is put a cork on either side with a vacuum tube going through a metal one with a valve, so I can take the pressure out of here. What we're going to do is use these wires in my Mobius coil, which is going to be a great experiment. And what we're going to do is run the plasma from that driver through the bottle, out the backside. I'll drill a hole here and do the same thing with the cork and a valve. So there'll be a node and a cathode, basically. So it'll directionally the plasma. And then we're going to fire up this coil with first DC variable to see if we can choke down the plasma. And choking the plasma, be controlling the plasma. So in this experiment, we're actually going to see in space itself what happens to our electrical energy that turns into plasma to gases. It turns in from light itself, from the source, the sun, where it comes up against the planet or objects. It's got to slow down that light propagation, and I would think the elements in there get caught up into their once they slow down, they're able to, you can pull the aluminum out, the copper out, all the ingredients that's in the light itself that's able to show up as congealed space ingredients, so the planets and the universe can use its material to make matter. So in the bottle experiment, the plasma that would be out in space would be light that's going by planets and slowing down. And is it a couple? I have a lot of questions, but we'll dig up more questions. If you have any questions, please leave them. What happens to the plasma as when in presence of a magnetic field? So the magnetic field here would be a Mobius coil, meaning this is a perfect dielectric nodal point, because the center part of this is where the two positive and negative come into each other and create the nodal point. So on this Mobius setup, we're going to see plasma in a beautiful way of being able to find out some questions, which is, does the magnetic field influence? Can we control the plasma with the magnetic field? So that means, like I said on a couple of videos ago, how sound will control and line up everything. We are creating a chamber here. In space itself, there's got to be sounds, but if nobody can hear the sound, the question is, will you have propagation of audio through space itself? Obviously, we can hear things and we can send a signal, but we have to receive it and then make sense out of it. So it's not really what it is of how we want it. It's really how it is in the medium itself, and we just have to flip it around like a Rubik's Cube and make it make sense on our end so we understand it. So this would be a great experiment with vacuum, without vacuum. We'll check the colors of the space itself. I want to show you guys, as you see, the electric will run through here first, and then you'll see the color of the electric. It'll be more whiter and brighter. And as you add a negative vacuum into the space itself, you'll see the plasma blue start to show up. Obviously, we talked about the color of the light itself, we'll call it, which is be more blue, which have more nodal points, versus red would have less nodal points. Hope you guys like this video. Sorry about 29 minutes. We're bouncing out of here. Say goodbye, pups. Peace out. Leave your comments.